So, the next topic after me would be about the I frameworks, some unusual application of these frameworks. I hope you'll see it's from a bit different side. So, the agenda, I'll give you some overview of like most popular frameworks. Uh, I'll show how you could use these frameworks for mocking, for some flexibility in mocking, and very interesting part about caching of the object of these frameworks. So that's probably most popular frameworks that we have: Swinjet, Resolver, Needle from Uber, and Cleans from Squad. I just tried to find some ratings. This is like probably it, the top of it. You could see that Swinjet have much more scores, probably still the most loved one. So main idea of these frameworks, like you register some of your servers, like you say how to create them on one side of the project, and now you could use them really on some other side of your system, of your project, get this value that you register. So deliver all these services to some different part of your project. So that's like the main idea of probably all of these frameworks. Of course, they like have different details about it. How do you actually access these services? Is it property wrappers or maybe some other ways? Also, how you register these services, how you register these factories to create actually these services. Also, very usual issue regarding all these frameworks, it's verify that still they don't, that's stuff that you register actually could be resolved, or the stuff that you try to resolve, you actually register it. So they all of them need some kind of verification. So all this, the whole system works. And as I already mentioned, also if you create these services, you come to the question how to share this object. Probably just create. It's not what you want in all the cases. So you need some different policies for this, and these frameworks help you with this. And most of them have quite similar structure inside. You have kind of container where you actually register all these services. And this container would hold them for some time that you want. And the consumer, so somewhere in the project, some modules, some classes or whatever, could call this, use this container to get the service that you registered. In simplest way, you could use some static or global variable, like this dependency shared. It could be somewhere internal if you do it through these property wrappers, but still the principle probably the same. A bit smarter approach for this, not use this global variable. Global variable probably not this good, right? So you could also spread it with instance with some reference of this container. Then in that case, you're a bit stricter with usage of the services. And this container probably could be not just one. If you have many different modules in your system, could be like separate containers for for each of them. So it's not necessary to have only one. You could have many. Also, these containers allows you usually to create some hierarchy with them. So I have one basic, and for them, again, for smaller models, have additional child containers that also could reuse the basic one to get the services. And like, why do we need these frameworks? So what usual reasons to have them, to use them? Probably the main one, like to do things right, to have like to write proper architecture, like clean architecture. Of course, we all know this solid, right? The last letter of it. So like to follow all these nice principles. And probably less theoretical, but more practical, it's of course testability. To actually write the test to have our code actually stable, not just to do this nice architecture, but really to make the code testable. And yeah, I jump back to the frameworks. I would say that I have experience working with Swinject, Resolver. Also tried this DI Tranquility. We haven't tried Needle and Cleans. Among these four, Needle is quite special because it also have validation during the compilation. So they not just to do this in runtime, but also check that's the stuff that you register during the compilation that it would be delivered. Yeah, and now the most interesting part. So like unusual side of it. So usually we are so excited about this delivery part that we deliver. How do we deliver these services? How we solve this solid part architecture question? But also for these frameworks, there's also nice thing for providing actually the mocks for your test. And one of these, like you could use this container as like anything resolver. What I mean with this. So imagine just usual unit test, you have your system under the test, right? So it has some dependencies and you want to test some small feature of the system. Maybe this feature actually don't really touch any of these dependencies. So you want to test something that do not relate to any dependency. You do like, you want to test all this small part and you don't want to care about all this additional stuff that you need to provide for actually for this. And you maybe could do this hard way, provide like all the mocks, or maybe you could provide some dependency provider that actually should do the resolving. And resolving could be, like if we simplify it, to the small parts, like could be something that's provide you actually the object. Like you could imagine as some variable with forced unwrapping, some optional with forced unwrapping. You don't until you don't touch it. So maybe it could be actually nil, but until you don't touch it, everything good. So you could imagine that it's here, and if your feature don't really use any of this stuff, you probably could run the test and make thing done. So if we now reconsider the structure of the frameworks, this container with factories, we could imagine like this: a container without any factories. It still could resolve anything for you because this resolving function is usually some kind of generic that's ready for any type you want. And if you provide this to the dependency provider, actually, so you could come to actually this part. So you have your system under the test. For dependency, you use this container that don't have anything inside. And again, until you don't touch it, still everything good. You have all your mocks just for free, for nothing. And this was like the simplest case, like the simplest strategy, how you could get these mocks. But of course, it's not only one. So I mentioned now we have a bit more complicated case. We have this system, and now we have the feature that actually needs some kind of dependencies. In that case, we could maybe not use the simplest variant where I have like no factories, but use it as a basis and add more factories over it. So we use a simple empty container, add some mocks that we really use in this feature. And now we have again resolved the dependencies that's needed just for this test, for this feature. And now we have it again cheap as much as possible. So stuff that's not used, we don't need to provide any mocks. And stuff that we touch, in that case, we give the mocks, set up them properly to give the proper data. Yeah, in that case, it's as cheap as possible, probably. And one more strategy that I'd like to mention here. So it's not always necessary to have this empty container as a basis. You also could do it opposite way. So you could take this container from your production part, So how you usually do this in your like main production application? So like the container full of your production services, and replace some of them with the mocks. So in that case, you could still have some of your services really with real implementation, and some of them could be mocked. In that case, you could even do some integration test with your system. So you could some of your services I mentioned would be real, so you could check how they work together, and some parts that won't work during the test, that's not possible to use during the test, they would be actually mocked. In this case, you could really check it in some also in some edge cases, in errors, in delays, and so on. And so not only mocking we get from these frameworks. Another one very interesting side. It's actually this sharing objects, or usually in frameworks they call it as the scopes. How you register the services, how they would be used in the system. Usually, of course, like different frameworks have different scopes, so different list of them. That's probably the basic cases. It's like singleton, cached policy, cache scope, shared scope, and unique. The simplest scopes are these two. So singleton, very usual story. You create it once, and it works like until the end, or maybe even more. Another one, unique, where you create new instance each time you want to get the service. So each time you touch it, new instance of the service will be created, and you'll have like the new unique instance for your work. A bit more complex story with the cached scope. In that case, so as I mentioned, you could have more containers in your system, not just one global and static, but like containers, special containers for your models. And in that case, the services could leave. This could be limited with the time life of with the lifetime of these containers. So if your modules stop working, so you don't need it anymore, it's delegated, container delegated, and services also delegated. So in that case, they are not like singletons, but limited. And my favorite one, this shared policy. Like to be illustrated, the best illustration for it is the container actually have like the big reference to the service that you create in your factory. So any user of this service, they still could get the same instance until you have a reference on it. So until you have some users of the service, you will share the same object. If these users delegated, if they gone, then the service would be also delegated. Some use cases to illustrate it. Here, our SwiftUI view. When you recreate the structure, like a new instance, usually in that case it replaces the previous one. And if you use this shared policy, in that case, the new instance could get the new structure of the view, could actually get the same instance of the service, or it could be like view model or whatever. So in that case, you could keep it for the same time for the as actually the view the UI element. And another one very useful case, like I also like to use it. So if you have some complicated component with lot of elements, some sub views, sub components inside. In that case, you also could use some service in the basic component, and this way very easy have access to it in these child components. So you don't need to provide it somehow from parent to child, but just use resolving and gets the same object. Also very useful. So as you could see, with all these policies, the TI frameworks actually could be considered not the thing that's like you create it here and use here, but quite opposite. That it could be really the core of your module. So something that's maybe not spread more than just really concentrated in one class, in one file. And you could use these features of scoping, of resolving really only here, and don't try to spread it somewhere else. Even in that case, they still could be useful because of these two moments, these scopes and this like resolving for anything. So after this presentation, I hope that you could notice that these frameworks actually could be used to control this core services that you have in the system, control their lifetime. Like with them, you could very flexible change it from singleton to this scoped part, or maybe even shared, or even maybe like unique. So if you want to recreate and have a unique instance for every module, like this is very cheap way to mocking in some stories, and also you could with this stuff you could really very flexible have different level of mocking. So not just mock everything, don't have any production part, but also have use more live parts. And yeah, maybe you remember my story regarding interactive tests. So that's also in this situation, this is also could be used like for micro apps, for all these small components where you have not where you use only small part of your system. So that's all what I have for today for this topic. And if you have a question ready, I'm happy to answer. I don't know. Do you need mic? Have questions? This is probably his first steps. Any questions? Probably not because of them, but the services that I could use, they could be like leaking by the users. The services who use it, the component that's use them, they could have some leaks, and only probably in this story. Otherwise, still you have good control. It creates the object for you, store the policy, and usually it's the stuff that's have really long time. They you usually create them, and they really stay in the system. So I don't know. Actually, I would say that no, probably no. Break. I'm not sure that I follow. What do you mean? Yeah, yeah, true. Yeah, that's what I mean. Yeah, to be honest, I haven't checked this. I know what you mean. So all this like codable, not codable, but sendable, like story that should be moved from thread, like how we could call it right now, right? So the like director to rector. Uh, no, I haven't checked them. We in current project we like have implementation of these parts like separate. But they also was really proud that like they all most of them have the line that they are thread safe, And Swinject also still with good support. I I think maybe they have already. But yeah, strict answer, no, I haven't checked. Sorry, but maybe good thing to try. So, if no more questions, then we could finish on this. Thank you so much for attention.